Hi everybody, and welcome to the South Park and Kenosha Pass Railroad. My name is Stephen. Today we're going to be talking about controlling turnouts through DCC-EX. This will be using servo control turnouts with PCA9685 modules. Now I previously did videos on this topic. I'm redoing them, particularly since version 5.0 has come out. There's been some changes and improvements on DCC-EX, and so I'm going to kind of change some things and go over that new method of doing things. It will include, I will now be using EX Installer to add things and upload them to my Arduino Mega, and using HAL macro commands instead of the myHAL.cpp file. So if you've already seen my first video on this, you can continue using it that way if you want. It will continue to work. You may want to at least watch through the PowerPoint or the beginning presentation on this and skip through ahead about importing your previous sketches into EX Installer and using it going forward, and I'll talk about the main reason why I kind of suggest doing that. But you don't have to. So anyway, this is just part one of a three-part series. I'm going to redo all three of the videos I did on this, including using switches and push buttons to control servo turnouts in parts 2 and 3. So this is the introduction and basically getting servos set up in DCC-EX and getting them driving, or getting DCC-EX driving the servos through the PCA9685s. So we're going to head over to the PowerPoint, where I'm just going to briefly go over what you can expect from this video, and then we'll go on from there.
Okay, so let's talk about controlling turnouts using servo turnouts using PCA9685 modules through DCC-EX. And in this video, we're going to talk about what is the PCA9685, although you probably know, you may even have yours on hand already. How we address the PCA9685, we talked about the I2C addressing. How we connect the PCA9685 to your command station. We talk about powering the servos, because the command station will not provide enough current for driving the servo, so you're going to want an external power supply. We talk about daisy chaining PCA9685s together. You can connect multiple of them together to get more than 16 servos available. But there are issues with the I2C protocol. There's a limit to distance and the number of modules you can connect together. So we'll talk a little bit about what those issues are and some potential fixes to that. Then we'll talk about connecting the servo. That's easy. It's pretty simple, plug and play. Then we're going to talk about using EX Installer. This says version 5.0 and later, which is what I'm basing this on, is using version 5.0. If you have an earlier version, you're going to want to upgrade to that. We need to make sure you've backed up your config.h file and your myAutomation.h files. We're also going to need to add a couple of more files to it that we're going to build in, where we put in our definitions for our servos and for our PCA9685s. So we'll show how to add those in. And then we'll define the PCA9685s using the HAL macro. This is a change in version 5.0 instead of using the myHAL.cpp, although you can continue to use it that way if you already are, and we'll kind of cover on both of those as well. And then we'll talk about defining the servo turnouts themselves in DCC-EX and how to make sure your servo or your turnouts work. Then we're going to talk about importing your previous configurations into EX Installer. So if you were using an earlier version where you were making the myHAL.cpp and you had your turnouts already defined, maybe you had other things defined. You might have aliases, you might have macros, you might have signals, other things defined. Well, you can import them into EX Installer and they will work and come in. And so you can just continue using the EX Installer with those previous configurations, and we'll show how to do that. But you can also continue to use Arduino IDE, and I'm going to touch just briefly on that. One of the options you have going with that, if you continue using Arduino IDE and you're using version 5.0 or later, is using the HAL macro to define the PCA9685s instead of using the myHAL.cpp. They're very similar, but there's just another option on how you can do it. Then we're going to give a demo of the servos in operation. Okay, so this is the PCA9685. You probably already know that. You may have yours on hand already. 16 channels. There's 16 sets of pins along the bottom here for driving 16 servos, up to 16 servos. The top section here are these address pads, these solder pads. This is how we set the I2C address for multiple PCA9685s. If you only have one, you don't need to do anything. But if you have more than one, you set the addresses by just putting a dab of solder and making a connection between these two pads on each one of these spots. So that's how we would set the addresses. And based on what configuration of solder pads that you solder, we'll give it the address. And that's based on this. So nothing soldered gives an address of 0x40. The first pad soldered, as in the previous picture, gives an address of 0x41. And then on from there, up to 64 boards. So think about that, 64 boards, 16 servos per board, and I believe that's 1,096 potential servos you could have connected together. However, we come back to that issue with some of the I2C protocols that we're going to talk about here in just a few minutes, and some of the issues that brings up. Now, one thing to know, in DCC-EX, these first two are predefined, 0x40 and 0x41. So if you're doing 32 or less servos, you don't need to do any of the definitions for the PCA9685. Only if you have one that's addressed differently, if it's not addressed one of these two addresses, or if you need 3 or more, then we need to define it in DCC-EX, and we'll talk about doing that. Okay, so here's how you connect it to your command station. I recommend the Mega, just because of the memory. The Uno and the smaller ones just don't have enough memory if you start doing automation, or if you're going to connect a Wi-Fi to your board, there's not enough memory there. So we want to use the Mega, and we're going to connect the SDA and the SCL to pins 20 and 21, and I can see that these two pins here, and they just run straight through to the SDA and SCL pins on the PCA9685. You can connect it to either end of the board, it doesn't matter. It will work either way. The same thing with the power connections you make. So from your 5 volt to VCC and your ground to ground. And this is to VCC because that powers the internal chip. That's what makes it work and makes it smart. The V plus we'll talk about in just a minute, but make sure that in this connection is to the VCC. Okay, so now for powering the servos. Servos will just draw too much current. You can maybe draw one off of one of your boards, but you start driving multiple servos, you just draw too much current and the boards can't handle it. So you want to connect an external 5 volt power supply, something with a couple of amps or more depending on how many servos you've got, to be able to drive that. You connect it to the screw terminals on the edge of the board. They'll either be green or blue typically, depending on which brand of module that you have. Watch your polarity and just connect it there, but that's where your external 5 volt power supply for powering your servos goes. Now, daisy chaining multiple boards together, and that's pretty straightforward too. So you take the 4 connections you made on one end and you just continue them out of the other. So you've got your ground, your clock, your data, and your VCC, and you just connect that to the next board. Again, it doesn't matter which end you put it in or out, it can go either direction. Now here we've added a 5th wire on the connection between the boards, from V plus to V plus on the next board. This takes the power from your external wall supply and sends it down the line to all the connected modules. So that way you only need to connect your wall supply or your power supply to one module, and then you can connect multiple together. The only thing to watch is, depending on what current, what amperage you have on this power supply, again, you may be limited with how many servos that you could drive. So one of the things you can do to take care of that is you connect your power supply to here. You connect 2 or 3 or 4 of these together, however many you want to do it first. And then on this next one, if I connected another series down here, leave off the orange to the V plus. Connect the other 4 connections because that's your communication from the command station. And then on the next board, plug in another power supply to the terminal on the side, the header on the side. And that will give you a fresh power supply to the next board. Then you can daisy chain multiple together, including the orange V plus on the next series of boards. And so that V plus will be connected to that power supply on that board. Okay, so here we talk about daisy chaining the modules together and the issues with the I2C protocol. So the general guidelines on I2C is that it's good for up to about 3 to 4 meters, or approximately 9 to 12 feet. Once you start getting beyond that, you start having signal loss and could have problems getting the signal to the further boards down the line. Also, excuse me, the DCC-EX team suggests that using it through the command station, there's a limit about 4 or 5 I2C modules you can connect together. And the reason being is that I2C requires a pull-up resistor to work, to function. And they've determined that it's about a 1.9 kilo ohm resistor to make it work. Well, most of these boards have a 10 kilo ohm resistor built in, but when you connect multiple of these boards together and it connects them in parallel, it effectively drops the resistance value of that built-in pull-up resistor. And eventually, after 4 or 5 modules, that resistance value drops below that, I forget if it's 1.7 or 1.9 kilo ohm, whatever it is. It drops below that, and so you get an unreliable signal, and the I2C signal may not work. So here are a couple of the fixes. As far as for the distance, one of the things you can do is use Cat5 or Cat6 network cable. This is twisted pair cable designed for long distance data transmission, and it can help to increase the distance that you can send the signal a little bit, but there's still going to be a limit to it. So the other option is to use I2C extenders. I know of 2 of them out there. Adafruit and SparkFun each make these extenders and claim distances of up to 220 meters that you can run with these extenders. I haven't used one yet. I hope to eventually, but anyway, that information is out there. The other option is to remove the built-in pull-up resistors on the PCA modules. This would effectively remove that pull-up and then adding one resistor in the chain ahead of the first module that gives you a pull-up resistor to your Arduino somewhere in the range of that 2 kilo ohm or something. I'd have to do a little more research on that. But I have that in red because if you're doing this, you're desoldering resistors from off of your PCA9685, potentially damaging the board. So that's something to be careful about. It's certainly a little bit more advanced way of doing things. So I do plan to do some research on this I2C protocol issue with module limits and distances. And once I get that figured out and kind of figure what's going on, you can expect another video for me to cover that, and we'll be able to talk about adding more modules together. But in the meantime, just be aware of these limitations. All right, so the next thing is just connecting your servo, and it's pretty simple. Your servo has a 3-wire plug that just plugs into the module, and the only thing you do is watch your polarity. Now, the wiring on the servos may vary depending on the brand. You may have white, red, black, yellow, red, brown, or orange, red, brown. It kind of, like I said, depends on manufacturer. And the only thing to watch is the black or the brown is the ground, and that will go towards the bottom pin here. And then the top pin is either yellow, orange, or white, and that'll go to your PWM pin. They're all going to have the same red pin in the middle, and that's your voltage supply, so that's no problem. So just plug it in, and that's ready to go. Okay, so next we're going to go over, after this is done, and we're going to use EX Installer, as I mentioned. It's kind of a new thing that the team has put together. But in doing so, we're going to need to make sure that on your initial install that you backed up your config.h file and an automation.h file. So we'll just make sure that you've got those backed up so we can use them. And then we need to add a couple more files. There's 2 extra files that we're going to use in this method. Then we'll show how to add those to EX Installer. Then we're going to define the PCA9685s using the how macro. It used to be that we would do this in the myHow.cpp file, but they've come up with this how macro command that we can use to define it in, and we'll put it into one of these files. Then we'll define the Servo Turnouts themselves. This is where you actually define the servos so that DCC-EX will operate them. Once we get those defined, we're going to actually also talk about importing your previous configuration into EX Installer. So if you've used my previous method where you've used myHow.cpp, or if you've already got some stuff set up and you've defined turnouts, you've defined signals, you define other features that you've customized and used, well, I'm going to show you how you can import them into the EX Installer and continue to use those with the latest version 5.0.9, I think we're on right now, and use your previous configurations using EX Installer. And I'll go over the reason why you might want to do that. And there's one particular reason why you would consider using EX Installer over IDE. But if you do want to continue to use Arduino IDE, that's fine. And I'm going to just briefly touch on using the how macro instead of the myHow.cpp, and just that slight difference in between the two. Okay, so that's it. We're going to head over to the EX installer now and start setting things up from there. Okay, the first thing we need to make sure we do is we've got EX installer, we've got our config files backed up, so we can get set for this. So on the DCC-EX website, on the home page even, there's a link to the EX installer. I actually have a link to this page down in the comment below that take you right to the installation page. And we're just going to click on this automated installer, and it's going to ask you to save it. So I've got a folder that I've created for this servo testing video that I'm doing, and I actually already have a copy of it saved there. But you need to pick yourself a folder, someplace to save it on your computer so you can get to it. Now I've done this because I'm going to add my configuration files in the same folder. And it just makes it easier for me to find it. It's just right there with the installer, and the config files will be there that I need. So save the file. I've already done so I'm just going to click cancel. But save the file someplace where you can get to it. And then once you've got it saved and your window closed, you need to go ahead back to that folder and click on the installer. We want to go ahead and run it. Okay, so if this is the first time you use it, this may look slightly different, particularly as we go to the next screen. But it's just welcome to the EX installer. Help you get set up to get DCC-EX installed on your Arduino. So click on the Manage Arduino CLI. CLI stands for Command Line Interface, and it's how DCC-EX installer works with the Arduino. Now I've already got it installed. If you don't, if this is the first time you're using it, you'll have a different button that probably says install. I don't remember exactly what it does because it's been a while since I've done this. But once you've got that done, you just click on install to install the CLI. Once you've got that, you'll select your device. So it'll scan for your device. If you don't get anything here, it'll come up with an error message that might say, hey, no device found. Is it plugged in? Make sure that you've got your Arduino plugged into the USB port. I already do, so mine has come up. I'm using an Arduino Mega. So I'll select that. Then we're going to select a product. We want Command Station. That's what we're installing. And we want the latest production version. They've just updated this in the last day or so to 5.0.9. So we'll take that for the latest. So initially, we're going to do the configure options on the next screen. So make sure you got that selected. And so we'll go to the next screen. I do have Wi-Fi. That's how I connect to my DCC-EX. If you don't, you can leave it unchecked. But you want to select the things you have here. We want to create a myAutomation, and we want to do advanced configuration. So since I do have Wi-Fi, I would set up my options here. I'm using it as an access point, and I'm going to set a password for it. And in this case, this is just a test that I'm doing. I'm going to just call it Servo Test, so I know what my password is. And then back into the General tab, we need to select our motor driver. Again, I'm just going to use a standard motor shield. Once all that's done, we'll go over to the Advanced Configuration tab here. And so you can see it created the config.h file and the myAutomation. Now, there's nothing in the myAutomation except for just a comment that they put in saying that it was generated by EX installer. But in the config file, it's got some of the stuff set up. So it's got my standard motor shield defined. It's got my password for the Wi-Fi module that I put in, and it is enabled as true on channel 1. So there I'm set and ready to go. We will now compile and load it. And when you click the load button, it will compile the sketch and upload it to the Arduino. Okay, so it has successfully been loaded onto my Arduino Mega. Here is what I was trying to get to though. We need to back up these config files. Okay, so we'll do that. We'll click on this backup config files button, and we're going to browse to where we want to put it. And I'm going back to that same folder we were in, that Servo Test, and we're going to just select that folder. then hit backup files, and it says my backup is successful. All right, so we've got our initial setup and install onto the Arduino. So next we're going to go again back to that folder, and you can see it created those two files, the config.h and the myAutomation.h. Now if you first time here, I do recommend you watch my other video on compartmentalizing DCC-EX. If you've seen any of my videos before, you know that I do that. I separate everything. Technically, everything we're going to do, you could just put straight into the myAutomation.h file. But if you start configuring turnouts, if you start configuring signals, if you start configuring sketches or automations, plus defining all your devices, that can get pretty hard to keep organized. So I put everything into subfiles. DCC-EX team does talk about that on their website at one point, and pretty much it's pretty easy. I'm just going to create two subfiles here, and I'm going to do that here by creating a new text document, and I'm going to change the name of it, and in this case I'm going to call it myHowDevices.h, and I'm going to delete the .txt. Okay, so myHowDevices.h, and I'm going to be using the same naming conventions that the DCC-EX team uses. So the first my is lowercase, and then the first letter of that second word is uppercase. So in my case, my how, the H is uppercase. When I hit enter, it asks me if I want to change the file extension, because remember it was creating a .txt file and we're changing it to a .h. So yes, we want to change that extension, and that's fine. That's what it should look like. We're going to create one more, another text document, and I'm going to call this one my Turnouts.h, uppercase on that first T, and I'm going to delete the .txt. Again, I'm going to get that error message. Yes, I want to change the extension. So now I have 4 files in there, and that's all we need to create for now. So we're going to go back to EX Installer, and you could have closed it. You could close and start all over, but we're already here, so I'm just going to go back all the way to, well, that's one too far. That's fine too, though. We're going to choose our command station. We've got our production version, but now we want to use our existing configuration files. We're browsing, we're back at that same folder, and I'm going to choose the config.h. And now when I go to advanced configuration, you can see all 4 of those files are here. So the config.h is still set up as it was, the myAutomation with nothing but the comment, and then 2 blank files that I created. Okay, so let's define the PCA9685s. DCC-EX has 2 predefined in the base system, in the base software. So if you're using less than 32 servos, you actually don't need to do this step. But if at some point you need to add extra PCA9685s, you would do it here. The first 2 are defined under I2C addresses 0x40 and 0x41. So if you remember at the beginning of the video through the PowerPoint section of it, and I showed about addressing the PCA9685s, if you were just using those first 2, you would leave one with none of the address pads soldered, 0x41. The second one, you would solder that first pad. I want to be able to add more than that. So if I'm adding a third PCA9685, we're going to do that here under the myHowDevices. And we're just going to type in this command. It's uppercase how, open parentheses, what we're defining. So in this case, it's a PCA9685. Comma. Now we need to tell it the first address of the first pin on the module. So since we have 2 already defined in DCC-EX, 0x40 goes from pin 100 to pin 115 inclusive, so that makes 16 pins. The second one, 0x41, is from 116 to 131 inclusive. So I'm going to go to the next one. You do not have to go in order. I could jump to address pin 300 if I wanted to. But I'm going to continue in order, and I'm going to give it the first pin number is 132. That would be the next pin in order. Now we need to tell it how many pins that there are. This is a 16 pin module, 16 channel module, so we know there are 16 addresses. Okay, now we give it the I2C address. We know that 0x40 and 0x41 are already predefined. So I'm going to use 0x42, close parentheses, and there is my definition for adding PCA9685 to DCC-EX. I'm actually going to add one more just for the heck of it, because I'm going to show you all something later. PCA9685, comma, 148 would be the next available pin, comma, 16 channels or 16 pins available, 0x43, close parentheses. So I now have two PCA9685s defined. You can define as many as you need, to get whatever you want for your sketch. All right? Okay, so we've got our PCAs defined. Next, we need to define our turnouts. That's what this myTurnouts.h folder is for. I'm going to define my turnouts in here. Again, it's with me compartmentalizing everything and just keeping it separate. So I'll just have my turnouts defined here. So the command for defining the turnouts is this: uppercase servo underscore turnout, open parentheses. Then we're going to give it an address. This is the address that DCC-EX recognizes for the turnout. It's what it uses for identifying the turnout. And I'm going to start off with 100. And the reason I am is because comma, the next digits I'm going to enter here is the actual pin that the servo is assigned to. So if you remember in the last step, I talked about there are two PCA9685s predefined. The first one starts at pin 100 and goes to pin 115. It's the 16 pins on that module. So the first pin is pin 100, and that's where I'm going to plug my first servo. Okay. Next, we're going to talk about the two positions of the servo when you throw or close the turnout. So the first position is considered the active position. When you activate the servo or you throw the turnout, this would be your active position. Most servos, particularly using these SG90 micro servos that you can get all over the place, the range is usually for a 180-degree arm or motion servo. The range is between the number 100 and 400 that you would use here. You're going to have to experiment with the final number, and we'll get to that later in the video when we talk about using EX Toolbox to be able to determine the proper positions. But I'm just going to start off with an example of we're going to use the number 350 as the close position, as the thrown position, comma, then the next digit is the close position or the inactive position of the servo. And I'm going to go to 150. So that's going to give us our 2 points that the servo is going to turn to between 150 and 350, comma. And then the next is the profile of the servo. And this has to do with how fast that the servo arm moves. And there's 4 speeds. And all of them start with the first letter uppercase. And in this case, I'm going to start with instant. There's fast, medium, and slow. But the first one we're going to do is instant. Next, this is an optional field. You can give it a name. So if you're using, say, engine driver to control your layout, especially if you're connected wirelessly, this is the name that will appear for your turnout when you go to the turnouts in engine driver. And so with a quotation mark, we're going to give it a name of turnout 1, close quotation mark, close parentheses. So we've defined our first turnout. I'm going to actually do a couple more, and I'm going to do them just quick here to get them defined. I'm going to show you one thing slightly. I'm going to do slightly different on one of them. Okay, so first do is changing the ID that DCC-EX recognizes, and we'll go to 116 because that's the first pin on the second PCA9685, and that's also the same pin. I'm going to leave the close and throw positions the same, but I'm going to change the profile to fast, and I'm going to call it turnout 2. And then, of course, the third one is on number address 132, and it's on pin 132, and we're going to give that one a speed of medium. We'll call it turnout 3. And then the last one, I'm going to give it a different address. I'm going to give it a ID, I should say, of 150. But it's going to be on the first pin of that fourth PCA 9685. So it's actually going to be on pin 148, even though I'm giving it an ID of 150. And we're going to change its profile speed to slow. And I'm not going to give it a name. I just want to show you what happens when we do this, okay? So we have our 4 turnouts defined. Now, since we did these subfiles, at the moment DCC-EX won't recognize them and won't know what to do with them. Everything that happens comes through the myAutomation.h. So we need to tell it about, hey, you need to go get the data out of these other 2 subfiles. So under myAutomation.h, we're going to add these 2 commands. And it's an include command, # lowercase, include, and then in parentheses, the name of these subfiles, these two subfiles. We're going to do 2 of them. My how devices.h and # include my turnouts .h close parentheses. Now I used the wrong thing right here. That should be #, not $. Okay. So then we'll have our definitions and ready to go. And we would go over to a compile and click load. It's going to compile. Now this one came back quick. I got an error, and I did this on purpose kind of because I just wanted to show you. And it failed. It said error during build, exit status 1. And in here under the description, it says myuurnouts.h, no such file or directory, under the command include myuurnouts.h. So all it was is that I mistyped here. So I'm going to go back one to my configuration, and back under my automation where I typed that in, I'm just going to fix that and call it my turnouts.h. So that was what it was. I just had a turnout a typo, and I just kind of did that on purpose to show you if there's an error, it does show up there. So now when I configure the load button, it should compile and load successfully to the Arduino this time. Oh, nope, I still have an error. Oh, I see, I got another misspelling. Let me go back to the configuration, and under my turnouts, these should be Servo. I'm missing my V on all 4 of these. Okay, let's try that. Okay, it's successfully uploaded. All those mistakes I made did fix it. I do want to back up these config files because I want to keep those so that if I come back and make changes again, it saves them. If I just close out here, all those definitions I just made would go away and it wouldn't save them. So we're going to browse back to that same folder, back them up. Now we're going to get this existing files found, click overwrite to overwrite them. Files found config.h. Yes, we want to overwrite them because we just made these changes and we want them to be there next time we come back. So the backup is successful. So now we can close out of that and we would actually be done. And just for the heck of it, I'm going to reopen it just so that you can see by backing it up. And I'm going to go real quick through, select my device, select my product, browse for my file, select config, advanced configuration, And you can see that those folders are still there, and it's got all the definitions in them. It did back them up and save them. So anytime you come back, you can just make continued changes from there. Okay, so I want to touch on one more thing about making changes and updates to these files. And obviously I'm showing in here doing it through EX Installer. One of the things that I don't care for about EX Installer is that you have to be hooked up to your Arduino and connected and loaded before it allows you to get to these configuration files. So I work on this stuff a lot of times where the command station is hooked up to the railroad, it's working, and I'm sitting watching TV or doing something else where I'm making updates or changes to my files. Then I just bring my laptop over to the command station that's permanently hooked up to my layout and just upload stuff to it. Well, I can't really do that here. So there is a workaround for that. And basically what I do is just use a text editor to edit these files. So, and these all have the default for it. I use a text editor called Notepad++. You can use WordPad, you can use Word, you can use the built-in Notepad. I just like this one a little bit better. So let's take the myHowDevices.h and I'll open it up in this text editor. And I'm just going to add, just for the heck of it, another device. How PCA9685, comma, 166, I think that's the right number. We'll just put it, that'll be fine. 16 pins, an address of 0x44. Okay, so then I'll just save that file. And then this is from something different. I'm going to open up that my Turnouts file, and I'm going to add another Servo _turnout. What did I do there? 168, 168, 350, medium. Oops. Medium, turnout _4, and save. So it allows me to make edits and configurations in this text editor without having to be hooked up to the command station. And now when I go back to here, we're going to go back and kind of refresh everything. See, it brought in those new changes that I just made. That actually PCA9685, the turnout that I put in. So it's just another option on how to edit the files themselves and then bring it into the installer to get it uploaded to your device. Okay, next I want to talk about importing your configurations into here. What I mean is, if you've been using Arduino IDE, you use the original method that I gave of setting up turnouts and any other kind of configurations you might have done through IDE. You can import that into the EX installer. And there's one main reason why you might want to do that, and I will show you here. But you can do this and keep all your previous configurations without having to start from scratch. So we're going to go back to the select version where you start just like you normally would, where you would get to this part where you're going to select your configuration files. This time we're going to browse to the folder where you have your command station installed, and you'll see all those files from the IDE installation. There's a lot more to them. And do the same thing here. You just select your config.h, and then when you go to your advanced configuration button here, you can see all that stuff that you previously created is now imported in here, including the myHal.cpp, where we defined our PCA9685. You can define other items in here. But here's why you might want to bring it into EX Installer. All the tabs for your configuration stuff are right here, including the stuff that I made separate. So the my turnouts, the my signals, all the other stuff that we did in other videos, are here without all those other tabs that show up in IDE. So it makes it easier to find the files that you need to work on, because these are going to be the files that you customize. And so you can still use the myHal.cpp and find your configurations here and make your changes to it. And then you can compile and upload it, and it will work just like if you created it all originally in this EX installer. Okay, there it completed a successful upload. So all of those configuration files, and if you're making changes, don't forget to back up your config files. It'll back up those same files that you just imported. And even if you open up Arduino IDE again, those changes will be there if you go that route. But anyway, don't forget to back them up. And it just gives you another method of being able to work on your files. And like I said, it's just a little bit easier working with these tabs than with all those IDE tabs that you got to scroll through to find everything. All right, there's one last thing that I want to talk about, and that's if you want to continue to use IDE as your compiler. You can do so easily as you were before. You may want to consider changing, instead of using the myHal.cpp, using the HAL macro I showed earlier in this video. And basically all you would need to do is under your IDE where you've got your sketch. If you want to switch over, basically you would just create a new tab, and we'll call this one myHalDevices.h. And in here is where you would use the HAL command to define your PCA9685. So it's pretty easy. Uppercase HAL, open parentheses, PCA9685. Comma, okay, then we're going to of course give it the first pin address for the first pin we want to use. Let's say we want to use 132. We know it's 16 pins, and then we give it our I2C address, 0x42, whatever the case may be. Okay, and so that's it. So now when we compile our sketch, it will pull this stuff. Of course, you got to remember, I almost forgot, you would have to go to myAutomation.h and include in here in parentheses myHalDevices, not parentheses, quotation marks, I'm sorry, .h. And so that will go out and get that file like we talked about in the earlier videos, like we were showing with all these others. All these are commented out at the moment. So that's it. That's just another way. Again, you can continue to use IDE. You continue to use the myHal.cpp if you want, or if you want to use these macros and use the myHalDevices instead. Just one other option on how to get all of this stuff uploaded into your sketch. Okay, so that's it. So we have everything defined and uploaded to our command station. We are now going to switch over and do a demo of that to show how they show up on Engine Driver and how they control the servos and the different speeds.
All right, let's show how this works. Please excuse this crude setup for this demo, but to be able to show the servo actions, I really needed to just set them up on top like this and not connect it to turnouts. So we've got our 4 servos back here that we defined and our 4 PCA9685s. So I've got one connected to each board just to show the multiple board connection. To the first board, we've got 4 wires. Those go off to the command station, and that's the data, the clock, the VCC, and the ground. Then from there, we have 5 wires to each, like our earlier diagram. We added that 5th wire, which is the voltage plus, to drive the servos. That power is coming from here. This is a wire that's going off to a 5-volt wall wart connected to the green terminals. And because of that 5th wire, that sends the voltage to all 4 of the boards to supply power to the servos. Okay, so we're going to use Engine Driver to control it, and I've got it installed on this old phone. You can have it on a phone, a tablet. And so it defaults, I've already made my connection, it defaults to the throttle. So under the 3 dots,
you've got this tab for turnouts. So we click on turnouts. So you'll see the 4 turnouts we just defined. Turnouts 1, 2, and 3 are the ones that we gave names to, 1, 2, and 3. That 4th one, we gave it no name, but it still shows up. And if you'll see, T150 is for turnout 150. That's the ID address that we gave it. If you remember, it's on pin 148, but we gave it an address of 150. Now, for some reason, when it comes up, it shows 2 buttons on that one, throw and close. But once we start using it, one of those is going to go away, and it's just going to look like these other 3 with just a single button. I don't know what that is. It's just part of the server.
One thing I want to add in here at this point, when I was first pulling this up, came up with an issue where when we defined our turnouts, we gave 3 of them names and 1 of them we didn't, so it just came up to its ID number. But I set up a new phone that I was using engine driver on, and this one with just the number wasn't showing up. So to fix that, under the 3 dots, and you go to Preferences, and make sure the Show Advanced Preferences is checked. Then scroll all the way down towards the bottom, and you see these turnouts and root preferences. If no name, hide if no username is checked. It seemed like that's supposed to hide the username, and that was checked like this. So I unchecked it, and then it showed up. For some reason, I've gone back and reset that to try and hide that again to show it, but it's not hiding it. So if you have some that don't have a name, and you go to engine driver and they don't show up, that's the setting you need to check, and then it does show up as it normally would.
If we take our first turnout, which would be this one over here, and it's on instant, so you get to see the speed, it moves quick. So we're going to take our second one, which I think is actually this one, I'm not sure. Yeah, that's fast, so it still moves pretty quick, but not quite as fast. And then this will be our third one, which is on medium. You can see how much more it slows it down. And those are the 3 with the name. So now the other one I was talking about, we didn't give it a name, but we can still, when we hit throw, you can see how slow that turnout moves. But you can also see on engine driver that it got rid of that second button and it's only 1, and now it looks just like the others. So as we toggle it, it goes back and forth. So there's our 4 servos working off of 4 different PCA9685s and our 4 different speeds, so you can see how that looks. The next thing you're going to want to know is that when you go to set up your turnouts, obviously you have to set that thrown and closed position in the command station that it stores. But how do you know what position to use? And it's only done by trial and error. But if you just go back to the sketch, you put in a pair of active and inactive position, upload it, test it, it's not right, put in another pair, upload it, test it, it's not right. That can go on and on and on and take quite a bit of time. So there is an app from the DCC-EX team. There'll be a link to this down in the bottom, and it's called EX Toolbox. So I've already got it on here on my phone. Again, same thing, we're going to make our connection. It loads, and under the 3 dots, there's Servo Programmer. You can see it as the top one up there. So if I select Servo Programmer, it gives us this screen here. So the first thing we want to look at is the V pin. Now that's not the address in this case. This is the actual pin that the servo is connected to. So we've got V pin 100, which is our first servo. That's fine. Then up here you have 3 positions that you can put in: throw, mid, and close. In our case, we don't need the mid. We're not going to even bother with it. It's not going to matter. So we're just going to go to, say, the throw position, and I'm going to change that number. And we're going to get a little out of focus here and there as I change this, but I'm going to change that to, say, 300 and do the close position to 250. Now, below that, you can see the profile. It's set on slow right now. I'm going to speed it up just a little bit. I'm going to go to medium, just so we can see it move. Okay, so those numbers are in here, and if I want to see what effect that has, now when I push either the throw button or the close button, you can see the servo goes to the 2 positions. So this allows you to test and say, okay, that's not quite right. Let's change this. It needs to be 320. So now when we test it, it gives us our next value. And we can keep trying it right here without having to upload it to the sketch every time we want to try a different value. Once we get it working and it's in the throw and close positions that we want, then you take these 2 numbers and you transfer it to the sketch. So the throw would be the active position. You can actually see it says there, right there. And the close would be the inactive position. So that would be the 2 numbers that you would enter into your sketch. Then you only have to do it once and you do all your testing here. It's a whole lot easier. So that's it. That's servos in a nutshell, driven through DCC-EX using PCA9685 for servo turnouts. Watch for part 2 and part 3 coming up soon, where we talk about adding switches and buttons to control these, as well as being able to use engine driver. And that should be coming up soon. Hope you'll enjoy this and have a great day.